Hello. You probably remember that our first lecture was about research and about scientific research, and I mentioned there that scientific research should comply to the rules of scientific methodology. Therefore, here let's see what these rules are and what I meant when I said that. Let's first see this picture of classical sciences. You can see that the logic is in the core of every science. What does it mean? That no matter where you do the research, you have to reason logically. So your argument needs to be logical in order to convince others that what you're doing really matters, that it makes sense and it will advance the scientific knowledge. Mathematics is also basics of many sciences, in particular of natural sciences like physics, chemistry, a little bit less biology, and so on. And then the natural sciences are a part of social sciences because you cannot look at the social beings like humans in isolated way without connecting them to what exists in the nature. Humanities are even wider, so all the other sciences are included into the humanities. And outside of this onion picture, we have the cultures, the religion, arts, and so on. As you can see here, we do not have computer science, and it has even science in its name. Why is that? That is because this kind of branch of the science developed much later. It developed in the last 100 years or even less. What does it tell us? It tells us that sciences are dynamic. So, and also are the methodologies to which the research in every science needs to comply. What about technology? Let's look at this picture. Here you can see that we have research and science almost overlapping in a large part, and then we have a small part of technology overlapping with science and research. And the development is everything, both research, science, and technology. So when we talk about the science in technology, we actually talk about science inventing tools with technology that would be useful to the humans. Let's see now what do we understand as scientific method or hypothetical deductive method in this course. This method was supposed to be a unique method that should be used for research in any kind of science. However, you can still see differences. Even some of natural sciences think that this method is not good. However, this is what we have by now. So the steps in these hypothetical deductive methods are the following, and we have these steps explained before. This method starts with identifying the problem area, identifying where you will do research, in what narrow topic, and what problem you will address. After you know that, you can define the problem and have the problem statement. Once you have the problem statements, and this is associated with defining your aim and objectives. From this, you can develop some hypothesis or something that you think that is everybody agrees on now, and maybe you will try to prove that this actually you can prove with experiment or with your research that this hypothesis can be falsified or that it is not true. Or if you don't do that, then this hypothesis will stay and still everyone will comply with it. In order to test the hypothesis, you need to determine the measures, what you will measure, and how you will test this hypothesis. And of course, you need to collect data and to analyze them. As a result of this data and the analysis, you will interpret the results you will get, and you will come to a conclusion whether the hypothesis can be rejected or it is still there. This table here shows us that the different disciplines still cannot all rely on hypothetical deductive method. In this table we have three columns. One defines the sciences or the group of sciences, the other one the objects that are researched in these sciences, and the last one is the dominating method for research in these sciences. So you can see that we cannot implement hypothetical deductive method in logic and mathematics because they deal with abstract objects, with propositions, with numbers. Therefore, the dominant method in logic and mathematics is deduction or deductive reasoning. With the natural sciences and social sciences, we can have hypothetical deductive method. However, in social sciences, besides this one, we have something that's called hermeneutics. And I'll explain that in the next slide. Hermeneutics is also the principal method for the humanities, where objects of study are cultural objects like human ideas, human actions, relationships between humans, language, which is a human characteristics, and other artistic artifacts. Let's now see what hermeneutics is. It's a methodology of interpretations. It is usually concerned with problems that arise when dealing with human actions and products of these actions, and often hermeneutics is focused on interpretation of religious text. No matter in what discipline or in what area you're doing your research, these are the characteristics that you should follow. So these are actually the rules that I thought of when I advised you that when you do the research, you need to comply to the rules of scientific methods. So you need to do your research and show what's the purpose of this research. Because the purpose, as if you remember, we said it should be useful or of interest to a wider scientific community, not to you or your closest friends or family. It should be done with rigor or accurately. It should be testable. All your procedures that you use to show that certain hypotheses can be rejected or it cannot be rejected have to be testable, and you have to have all the details of how you perform the research so that anyone that wants to replicate can replicate your research. You should also do the research with precision and confidence. So when you have good results, you should be able to convince the scientific community that you have really done something good, something useful. Objectivity means that you should not uh, introduce your views or your beliefs when you do research. Research needs to be objective. We are aware that it's difficult to be done, but we should try as hard as possible. When you do research and you come up with some results, you want to generalize them for so that they are applicable to a wider area. For example, if you investigate that students concentrate better if they turn off the radio, the mobile phone, and everything that disturbs them, then if you do the investigation with some number of students, you would like to generalize and to have your claim, your hypothesis hold for the whole population of students. And the parsimony is also important for scientific research. Thank you for listening.